quotes from there too. So we'll figure out the answer to this here in a few minutes. You guys are all in the right ballpark there. So first thing that I wanted to do is there's probably 2 questions on the assignment if you did that from last night that I wanted to go over because you might not have known how to do them. Of all the questions, I'm guessing probably these 2 were the ones that tripped you up, especially number 106. So take a look at those if you've done it. And so yesterday we took these logarithms and we wrote them in exponential form, which taking this one would be x cubed equals 1/8 would be our first step. You take whatever the base is, the powers on the other side. And then what do we do to solve this? How do we get the x value solved here? How do you undo a cube? Yeah, a cube root. So you can take the cube root of both sides. That's what cancels out the cube. The cube root of, then you can just do each of these separately. The cube root of 1 is 1, and the cube root of 8 is 2. So the answer is 1/2. But a lot of people were getting stuck on what you did in that step. This other one's even a little bit more challenging. I didn't realize you actually have to use the quadratic formula. I assumed it was factorable, but it is not factorable. So you're going to do this as 5 squared equals x squared plus x plus 4. You're going to x from logarithmic exponential form. We then want to get everything on the same side, so we want to move this over. This is going to be the same 25. So we have x squared plus x minus the 25 over would be negative 21 equals 0. Typically, when you have 3 terms like this, you're going to want to try to factor it. You want to try to think, well, multiplies to give you negative 21 and adds to give you 1. Well, there's nothing that works because 1 and 21 and 3 and 7 are the only options. So you got to go to the nuclear option, if you will, and that is the quadratic formula. And if you don't remember it, this is here, quadratic formula. I'm sure you memorized it at one point. Algebra 2, right? All memorized it. Did the teacher make you memorize it?
I learned mine from the song a lot.
Yes.
Okay. I know there's like a row your boat one.
No, mine was about not singing in school. That's what I learned mine.
But it's one of those formulas that you should know. You might not remember it, but at least know how to use it. So these A's, B's, and C's come from the numbers in front here. These first 2 just have invisible 1s. And then, so then x is equal to, this is your A, this is your B, and then this is your C. Okay. So negative B, so this means negative 1 plus or minus square root of 1 squared minus 4 times 1 times negative 1 all over 2 times 1. So that's plugging it in. We then end up with x equals negative 1 plus or minus the square root of. This is 1 minus this. When you multiply it becomes actually a plus because it's 2 negatives. 84 over 2. And then we just get negative 1 plus or minus the square root of 85. It's okay to just leave it there for now. You can make this as decimals if you want to, but we'll just be good at that. I don't think there's any perfect squares inside of 85 either. All right, so those were the 2 hardest ones. Today we are going to get to some word problems. But before we do the word problems, we got to get a little bit of knowledge here, and then we're going to be doing a few word problems most of the period. So we're almost done with 5.4. And today we're going to look at word problems with E in them. But in order to solve a word problem with E, we got to know how to solve a problem that's just a regular problem. That's what we're going to do first. Let's look at a couple examples, and then we'll switch to the word problems. All right, so here's how we solve an E equation. right? It's not the technical name. It's technically an exponential equation, but specifically with something with an e, right? So we're given an equation with an e like this, and our goal is always, since math started, was to solve for x, right? So how do we solve for x here is the $1 million question. How do we get that x by itself? We need to get it down from this exponent and get it by itself. Anybody know how to do that? Any of you? Let's get the odd divide. What do you think? Okay. You got the right idea, yeah. So the division would work if it was like e times x. So that's a good thought too. But it is e to the x. That's a good thought. So something with not a square root. So yeah, kind of that idea. The opposite of an exponential is a logarithm. Okay. So and I guess we are essentially turning it back into a logarithm. But do you guys remember what logarithm is a base e? What log base e? What that is? What? Yeah, ln. Yeah. So it turns out what happens is logarithms and exponentials are opposites of each other, right? So like if you did log base e of e to the x, what do you think you'd be left with? Well, yeah, they cancel. So these actually, it turns out, cancel, and it leaves you with just x. Yeah, so what we're going to do in order to get the x down, since they're inverses of each other, logarithms and exponentials are inverses, is we take the natural log of this side. And you have to do everything to both sides always. So we're going to do a natural log of this and a natural log of. Oh, it's a little back up a bit here. Allow me to write. Right. So we'll take the natural log of both sides, and what happens is this cancels out with that. Because log base e is the same thing as natural log. And we do it to both sides, so then we have x equals the natural log of 5. So then, really the only note thing to write down then is if you're given an equation with e, you have to, we'll just call it natural log of both sides. It's not really a technical name, but a natural log of it. And then you'll solve for x. So that's like the inverse operation of the e, is natural log. And for now, we'll just leave it as a natural log of 5. You can find this on your calculator, and when we do the word problems, we'll actually write the decimal out because we'll need some context. But for now, you can just leave it as natural log of 5. But if you just plug it in, you can see it's 1.60, and it continues on for a long time. All right, so that's the basic gist of what we're going to do before we get to the word problems here. So just a couple more examples. So the natural log of e to the x equals 5. What would be the solution to that? These are going to just cancel. Natural log of e, those are inverses, so it's just x equals 5. Yeah, they cancel each other out, yeah. Yep. Ln's and e's are opposites. So on this one, we want to get the x by itself. So to do that, we're going to natural log both sides. I typically write it in cursive. One, because it's easier, you can just write it without picking up your pencil. But also that the L and the N kind of get a little bit confusing if you write it, because it kind of looks like a 1, it's like a 1 N thing. So I typically write it with cursive. I don't know if you guys know how to write in cursive or not, but anybody write in cursive ever? Yeah, they do. I don't know if they teach you guys still.
They didn't put second grade.
Okay. I don't use it a lot either, other than like math symbols and to write my name.
Yeah, as long as you know your signature, you're probably right.
Yeah. Yep. But yeah, it does make sense to use it in math. So. All right, so we natural log both sides here. We're left with just x equals natural log. And again, you can plug that in. We'll just leave it as is. And I just want to show you one more. Modify this one slightly. And this one I'm going to throw a 3 in front. So 3e to the 2x plus 5 equals 8. Well, just a little bit more complicated. This will be more like what we're going to be doing on our problems here in a second. Well, we want to actually get rid of the 3 first. So we just want to have the e by itself when we natural log it. So we're going to have, first thing to do here is to divide by 3. Because this is 3 times e, so we're going to divide by 3. This isn't going to look pretty as our final answer, but we're going to divide there first so that we have the e all by itself. And then once you get the e by itself, then you'll natural log it. So that's always going to be the strategy, is to get the e by itself first. Natural log both sides. And then we have 2x plus 5 equals the natural log of 8/3. And then from here, it's just using inverse operations to solve for x. I know it's kind of weird that you have like other letters in here, right? But just remember these letters are actually just kind of a number. Don't get too crazy with that. It is a number. This is just a number. And then we subtract 5. So ln of 8/3 minus 5. And then you divide by 2. So we'll just leave our answer like that. You could obviously make that a decimal. So now we should be ready to do some more problems. So just make sure you're following along when we do some calculator work. Make sure you type it in too. But we're just going to be going through these together. And we'll do some more of these tomorrow. I'm not going to have you do any of these for homework tonight. We're just going to just do them together in class today. We're going to start with this one about wounds, and then we'll do the drunk driving blood alcohol one next. All right. Some political here. I guess we're missing two of their teammates. But yeah, this one, it kind of applies to clinical care, any of the healthcare fields. But you can see how this one, like why math is actually sort of in healthcare and really everywhere. You might not necessarily see it if you're a healthcare worker, but like when if you were asked to like give a patient like a time to come back to get like stitches removed or like get something redressed, and you know there's a standard of like 3 days or 5 days or whatever. It's ultimately like based off of some mathematical model of healing. And so that's what we're going to look at here, is the rate at which wounds heal. So it says the normal healing of wounds can be modeled by an exponential function. If a, this is a sub 0, it also could be called a naught. It's just kind of a mathy way of writing it. A sub 0 or a naught represents the original area of the wound. So this here represents the original area. And A, this represents like the new area of the wound. So this is kind of the new area, and this is sort of the original. And this is a common format for problems like this, where we'll have our new amount, which we're trying to find, our original amount, and then E with some exponents up there. So you want to maybe write out this equation, because we're going to refer to this as we go. But that's what those different variables mean. Sometimes they'll change this, and on the problem could be a T, It could be any other sort of variable. We're just talking about wounds, and for whatever reason, A is representing the area. All right, so this equation describes the area of a wound after n days. So n represents the number of days following an injury, assuming there's no infection present to like sort of make the healing not work as well. Suppose a wound initially had an area of 100 square millimeters. So let's say like a 10 by 10 millimeters by 10 millimeters.
Square perfectly stamped around.
Well, I'm just like not like making it a little bit more simple, right? It wouldn't necessarily be that, but I'm just saying so you can visualize it. Right? More than likely it'd be something like this, right? You got a gash or something there. All right. If healing is taking place, after how many days will the wound be 1/2 of its original size? So we can use this model to predict when it's going to be half its original size. So using this equation, and again, I'll write this out, and you can just write A instead of A sub n. So I'm just going to write A. E to the negative 0.35. All right. So part A, we're asked to solve something. How many days will the wound be 1/2 its original size? So what variable are we trying to solve for? No, E is not a variable. Even though it's a letter, it's not a variable. What one represents how many days? N. N is the number of days, right? N is days. So after how many days, okay, will the wound be 1/2 of its original size? So we should be able to replace A and A naught, A sub 0. So the original size is 100. It tells us that. So that's our A naught. It's 100. So we're gonna put 100 here. E. Okay. E is just always going to be E. E is a constant. Negative 0.35. N is what we're going to try to solve for. So we shouldn't be able to plug anything in for N. That's what we're going to try to find, the number of days. What is A in this particular problem? What's like the new amount? Right. 1/2, so it'd be 50. Right. So we want to know from, we started with a 100 millimeter wound, when it's going to be down to 50 millimeters. Make sense? And then we're going to solve for the number of days there. Okay. So we can solve this now because we have just one unknown variable. E seems like a variable. Remember, it's not. It's just a number. So this is what we want to try to solve for that N up there. So just like we did on this example, I actually had I wrote a 3 up there, but we're going to try to get the x by itself. So we first need to get the e by itself. So we're going to be dividing first. We're going to divide both sides by 100. So that way we can get the e there by itself. So 50 divided by 100 is a half. We can just actually do 0.5 because there's decimals already in this equation. So it'll be 0.5 equals e to the negative 0.35 n. Everybody tracking so far? Okay, now what do we do? Yep, natural log it. So natural log both sides, I'm going to write it up here. So we got the natural log of 0.5 on the left side. And the right side, these cancel. So we got negative 0.35 n. Alright, so we're almost done. We're trying to get the n by itself. What's the last thing we need to do? Close. Even though it looks like it's a minus, it's actually just like a negative this times n. So we want to divide by negative. If it had been n minus, then we would add it. So it's actually both sides. So we're gonna divide both sides by negative 0.35. We'll have our n by itself. So here's we're gonna need a calculator. And try this on your calculator too. Don't just watch me do everything. You have to try it on your own. You need to go grab one. Give you time to do that. Practice plugging it in there. Just make sure you close your parenthesis on your natural log because it's always going to give you a natural log with a parenthesis and then you've got to close that. So we want to do the natural log of 0.5 divided by negative 0.35. And what do we get as our answer? Yeah, 1.98. So let's say approximately 2 days, right? In about 2 days, it'll be half the area will be healed. All right, now we're gonna ask one more question. How long until it's just 10% of its original size? So almost all the way healed, right? It'll be 10% of its original size. So how many days could we expect it to be, almost all the way healed? So like, a doctor would tell you, you can expect it to heal in this number of days. Right? Well, unfortunately, that's not how exponential growth works. It exponentially heals. Okay, so same idea though. We're gonna set up almost the same equation. So how long before it's 10%? So what's 10% of 100? Yeah, just 10, right? So we want to know when it's down to 10 millimeters. Okay, right? Because 10% of its original size would be 10 millimeters. So everything else is going to look the same here. We're still starting with 100 millimeters. And we got e to the negative 0.35 n. All we did was just change this new amount. Instead of wanting to know when it's down to 50, we want to know when it's down to 10. And then it's going to be the same steps. We're going to divide first. Ten divided by 100 is 0.1 equals e to the negative 0.35 n. And what's next? Yep, natural log both sides. This. Cancel, so we got natural log of 0.1 equals negative 0.35 n. Huh? Oh, you got the answer? Good. All right, and then the last step is going to be just to divide. So n would then be natural log of 0.1 divided by negative 0.35. So we'll just type that in, same way that we did last time, change it to a 0.1. So really you have a little formula there that if you want to know any different percentage there, you just plug in the percentage into it. And after you plug this one in, you should get 6.57 days, so 6.5, 7 days. Approximately 6.5, 7 days, yeah. So, yeah. We're gonna now do, that's kind of like an intro problem, not terribly difficult, but it's still definitely new. We're gonna look at the blood alcohol concentration problem here. I think you'll find this one pretty interesting. A little bit longer. All right. All right, I'll read through it here. It says the blood alcohol concentration, or the BAC, is a measure of the amount of alcohol in a person's bloodstream. A BAC of 0.04% means that a person has 4 parts alcohol per 10,000 parts blood in the body. Relative risk is defined as the likelihood of one event occurring divided by the likelihood of a second event occurring. For example, if an individual with a BAC of 0.02% is 1.4 times as likely to have a car accident as an individual who has not been drinking. The relative risk of an accident with a BAC of 0.02% is 1.4. So what this is saying is if you were to compare just a person who hasn't had anything to drink versus a person with a blood alcohol concentration of 0.02, so it's relatively low, but this person with a 0.02 is 1.4 times as likely to have an accident. So that's their relative risk. So even just having a little bit of alcohol, maybe like you had a while ago, and then you're going to go driving, just a little bit is still going to increase the relative risk of having a car accident. Right? And here's the equation that models it. R equals e to the kx. This is just saying the risk equals e to some constant, and then the x represents the blood alcohol content. So R equals the risk. E is just e. K is going to be some constant that we're going to actually solve for. Constant is just a number. And then x represents the BAC percent. So that's going to be our equation. And x is the percent concentration of alcohol in the bloodstream, and K is the constant. So there's our equation. The only difference about this one is, in the last one it told us what that K was. In the last one that was like the negative 0.35. And this one, our first task here is going to be to solve for K. We're going to find that constant K. And we're going to do so using the information that it gave us here. It says that the relative risk of a person having an accident with a BAC 0.02% is 1.4. So we're going to solve for K. That's going to be our unknown in our first part. All right, so what is R in this first equation? What is R again? Yeah, 1.4, the relative risk. The relative risk, 1.4, equals, E is always just E. K is what we're trying to find the constant K. So that's just going to be K. Yeah, good. And then the X is 0.02. Okay. So plugging that in, we have everything except for one variable which we don't know. And generally this is just written as like 1.4 e to the 0.02k. Just write the number right for us. Okay, so let's solve for k. What do we do first? Yeah, natural log both sides. We get the natural log of 1.4 equals, these cancel, 0.02k. And then we just divide by 0.02. And just make sure you close your parentheses before you divide. Else you'll get a much different number. So you should get 16.8 to 82, what's that, 824. So that's going to be our constant, 16.824. And we haven't actually solved for any sort of these other questions yet. We're just like building our model here. So our equation then is going to be R equals e to the 16.824x. So now we have an equation based off of that data that it gave us that we can use to answer the rest of these questions. So B says, using this value of K that we found, what is the relative risk if the concentration is 0.17? So if someone's been drinking a lot, their BAC is 0.17. So what is the risk of them having an accident as compared to a normal driver? So we're solving for what is the relative risk. So that means we're going to solve for R, right? R represents the relative risk. So B, R equals, E is always just E, 16.824. And then we need to plug something in for X that says that the concentration is 0.17, right? So that's going to go in for X. This one doesn't really require any math other than we're going to, as long as you plug it in the right spot here, and then now just plug it in your calculator. Go ahead and give that a shot. All right, what do we get? Seventeen. We guys got 17.46. 17.46. So about 17.5 times as likely. So someone with a blood alcohol content of 0.17, which is actually like more than double the legal limit. They're 17 times as likely to have an accident as somebody else. So not a good decision. All right. Next question is, using the same value of K, which we found, what blood alcohol content, so now we're going to be solving for X because it's asking us what VAC, that's the X, corresponds to a risk of 100. So this is saying, what would your blood alcohol content have to be for you to have a risk of 100 times as likely to have an accident? So let's figure that out. It's giving us a risk of 100, so that means we're going to plug in 100 for R. And then we're using the same equation here, e to the 16.824 x, and we're solving for x here for blood alcohol. So then we're going to natural on both sides, right? Because e is already there by itself. So natural log of 100. 16.824 is x. And then to get the x by itself, we're just going to divide. So we'll just type all that in. Then make sure you close your parenthesis after you type in 100. And get like a 0.27. So if you got a 0.27, then you're 100 times as likely to have an accident. So that would now be good. I don't know what the point of like dying is, but I'm sure it's higher than that. But right around there. Right. Definitely should have considered gravity.
I just want to make sure.
Yeah, I don't know.
Depending on that.
I've never been in that state of mind. So. All right, we got one more question. The last one is, so the law asserts that anyone with a relative risk of 4 or more, so basically if you're 4 times as likely or more, then you shouldn't be driving. You can lose your license. So at what concentration of alcohol in the bloodstream should a driver be arrested and charged with a DUI? Yeah, it is 0.08. And so that's actually what we'll find out here. If we plug all this stuff in, we'll end up getting 0.08. So it's saying the relative risk should be 4. So that's the marker that they've decided.
you mean anything above 0.08? Because if you're at 0.08, are you still
Right.
at the legal limit?
I think if you're at 0.08, I think it's still,
I thought.
yeah. Right. So they decided that 4 or more should be where you shouldn't be able to, it should be illegal. Seems like maybe that's a little bit too high. Seems like maybe like 2 is more. At any rate, if the risk is 4 times as likely to have an accident, then you can't be driving. You will get arrested and charged with DUI. So we've got 4 equals. That's our relative risk. E to the 16.824 x. So our last one we're going to solve for here. The way that you solve these is pretty similar in each one, right? It's either just taking the natural log first or dividing into the natural log. So ln natural log of 4 equals 16.824 times x. And then we divide both sides 16.824. We'll say there that it's 0.08. And that is the legal limit. If you're 0.08 or above, you do get charged with a DUI. So that person is 4 times as likely to have an accident as somebody else. There's actually a chart here that answers that question I asked you guys at the beginning. So you might be wondering, like, well, what does it take to get to a 0.08? Like, shouldn't obviously be drinking at all, anything in driving. But if you're curious, so like a 160-pound person, between 2 and 3 drinks would put you over the limit there. And it also depends on like the alcohol content of whatever you're drinking. This is based off of like one 12-ounce beer is what it says, like a low. Right. Yeah.
Girls can take what was it? You say there's a reason that girls aren't.
Yeah. They also normally weigh less.
Yeah, that's true. Yeah, I'm saying like body composition.
Right. Yeah. So here you can see the chart, and you can see as you get obviously way more, it affects you less. But in general, obviously you shouldn't drink anything and then drive. Just better not to do that at all. Let's see what we got. Oh, I might want to start this question. All right, so Grant, you actually work at you work at Valvoline, right? So one of this one uses Jiffy Lube, which is the same idea as Valvoline, right? Where you can drive in and get your oil changed. You drive into the garage there. Get your oil change. Which one do you work at?
I work in the area, so they'll put me in different locations. I get a move from here.
Okay. How many? Do you have any idea how many cars per hour come through?
It's usually like 40 to 60.
Okay. Different hours, probably more. Okay. So this one between 5 and 6 p.m. Probably is that when your busy hours? Between 5 and 6.
Busiest hours are probably.
Okay. What about like on a weekday? Even still on a weekday? All right. So in this particular example, between 5 p.m. and 6 p.m., cars arrive at Jiffy Lube at a rate of 9 cars per hour. So a fair amount per hour. And the following formula from statistics can be used to determine the probability that a car will arrive within T minutes of 5 p.m. So basically, this is trying to figure out what's the probability that a car will arrive within like 5 minutes or 10 minutes or so on and so forth. So our first question is, how many minutes are needed for the probability of 50%? So basically, how many minutes till we have a 50% chance of a car arriving in the 5 to 6 o'clock hour? So this will be the last one that we'll do here. So this f of t, this represents, doesn't really spell it out, but this represents like the frequency. Okay, so that's going to be what our 50% is. And anytime we use a percentage in math, we typically write as a decimal, right? So it's going to be 0.5, or our frequency, equals 1 minus e to the negative 0.15. And then we're solving for minutes, so that represents time. So then we're going to use some inverse operations to solve for t. Anybody know what would be the first thing we'd want to do here? We're going to get the t. We want to get the e by itself first. Yeah, we want to move this 1 over, right? So subtract 1 from both sides. So then we get negative 0.5 equals negative e to the negative 0.15t. Now we just have that negative to deal with, right? So we divide by negative 1. And we get positive 0.5 equals e to the negative 0.15t. Also, just a note is that there is no negatives in natural logs. So if you if you end up with a negative number here when you look at natural log, that means you did something wrong because you can't put negative into a natural log. Now in natural log, we have natural log of 0.5 equals negative 0.15t. And then so we'll divide by negative 0.15 on both sides. We get our t there. It's all that, and then we'll stop. It was about 4.6. So there's a 50% chance that the car will arrive within the first 4 minutes. So this could be used to like figure out like how many employees you would need, right? Like based off of how many cars are coming. You need 2 or 3 or 4 employees at this specific hour. We'll do some more of these tomorrow, so you don't have any homework tonight.